and I'm going to try to do these 9.1 questions and then finish 9.1, and so yeah, I've got them all the way down. It's just, I got one 9.3 question. We'll wait on that. So I've got several questions, so we'll do what we can, okay? All right, so the first one is 9.1, it's number 11 in the book. Can y'all see my screen? No, y'all can't.
No. Wait, what?
All right, I'm sending it to you again. Look for the blinking light. I bet you $1 Pendleton didn't. Pendleton, the first person did was this all up when you came in at Pendleton?
Yes, sir.
Okay, X out, and I'll bring you back in. I told him to X out. Go ahead and X out, and I'll bring you back in. Don't listen.
Hubert, can you send me an invite? This is Lucas Wilson.
Say again?
This is Lucas Wilson.
Oh, yeah, I won't add you to. Just hold on.
Thank you.
All right, can y'all see my screen? It should have my emails up. Easily, Oconee, can y'all see my screen?
Yes.
Oconee can.
Okay, well, make sure you can see my emails. Pendleton, you should be asked to accept, and you should see my email box there.
We can see it now.
Okay, good. Now we're ready to go. Okay, Mr. Wilson, let me pull him in. What's your first name again, Mr. Wilson?
Lucas.
There you are. Okay. So the first one, and you look at this number is in the book, number 11. So if you go to 9.1 homework and look at number 11, it'll look like this problem. The number in the homework is number 2, so that's the number you want to write down. 11/2. 11 in the book, /2 online. And it looks like y'all sent enough problems. We should have your 9.1 homework just about done when we get through. Okay, we went over one like this one before, but we'll go over it again because it is a test question, and a lot of people need to go over it because they're not used to working with radians. So, with that being said, what have I taught you so far? The first rule of trig is to find out what? Where you are. Find out where you are. So the first thing I'm going to do is I'm going to change this into a degree so I know where I am. Unless you're one of these people that think in terms of radians. And if you are, you need a life. Okay? So 3 pi over 10. And multiply by what? 180 over what? Pi. So the pi's cancel. Now you do not have to do it this way. This is the way I do it and the way I teach students to do it. The 10 cancels there. So somebody, what is 3 times 18? 54. So this is 54 degrees. So now you know where you are. Y'all check my math. This is 54 degrees. We know this is 0 or 2 pi. We know that this is what? Pi over 2 or what? 90. And we know this is pi or what? 180. So the reason I don't draw 270 is because they're asking for a complementary angle. We know that this angle given is 54 degrees. Or, what is it, 3 pi over 10? So you need to figure out what the other angle is. So you can do it 2 different ways. You can say 90 minus 54 degrees. And that's equal to what? 36 degrees?
Ish.
Y'all check me? Or you can say pi over 2 minus 3 pi over 10. And you got to get a common what? Denominator. And 10 is your common denominator. 2 will go into 10. 5 times pi is 5 pi. 3 pi. 2 pi over 10, which is pi over what? Pi over 5. Now, you can change 36 by multiplying by what? 180, pi over what?
180.
180. And you can check to see if you get the same thing as multiplying by 180 over what? Pi. Both of those should be the same thing. Now, how do you do it? I don't care. I tell students, I want you to learn how to do this stuff. This memorizing, regurgitation stuff doesn't do you any good. Okay? What do you mean learn? Well, you should learn first. Anytime you don't know where you are, you got to find where you are. So that's how you found the 54 degrees. Then you say, okay, 54 degrees, I'll draw 54 degrees and I'll draw my 90. That's how you learn this stuff. You don't memorize it. And I don't know what they want, but since they started with radians, we're going to finish with radians. With pi over 5, so that'd be pi divided by 5. So make sure you write this one down because you're going to see it on the test. And there's a supplementary. You do the supplementary. Of course, all you got to do is add 90 to it, but that's okay. Let's do it with pi. We know 90 plus 36 is what? 126? So your answer is going to be 126, but you need to add pi to pi over 5, and then you would be able to do it that way. Or you could say pi minus 3 pi over 10. Either way, hopefully you'll feel good about yourself. So since we know that supplementary is 180 degrees, we just go ahead and put pi over 1 minus 3 pi over 10. The common denominator is 10. 1 will go into 10. 10 times pi is pi, and 3 pi, and what do we get? 7 pi over 10. Now, of course, you could have done it in degrees. Would I mark it wrong? The only reason I would mark it wrong was because you negated one of the basic rules of mathematics and science. When you start with something, you what? Finish with it. You end with it, yes. So it started with radians, you want to end with radians. So I have to enforce that one. So 7 pi divided by 10. And you feel good about yourself. Capiche? Now I think you've got 2 or 3 of those in your notebook. Somebody check and verify. But there should be 2 or 3 of those in your notebook. You should have several of those. And you've also got 2 videos today and several days ago when we went over these. So the excuse you didn't know how to do those is pretty much gone now. You've pretty much got 4 or 5 different problems that you can look at. But that's a good question because that's a test question. So that's good. Next, number 29. I wonder if these are in order. Okay. 29, we've got, wow. Okay, I believe this is the gear question probably that we've been putting off. But now we can do it. Yep, there it is. So we might as well just go ahead and quit. Why? 1, it's a word problem. That's the main reason. And 2, we don't know how to do it. Right? What is S equal to? R theta. S is equal to R theta. We went over that last. S is equal to r theta, where r is the radius and theta is your what? Your angle. So you got radius, that's 9.32. Now theta is not theta because it's got to be in what? Radians. So we got to change 75/40 into radians. So go ahead and do that. Here's your calculator because it's a whole lot easier unless you just like whips and chains. I would use the calculator. So I'm going to go. I thought I had my calculator pulled up, but I guess I don't. The Russian took it off. There it is. So how am I going to do this? There we go. Pull this up. I got to juggle a second. Just give me a second to juggle. There we go. So I'm going to, first of all, you got to change 75/40 into what? You got to change it into decimal degrees. You don't have to, but that's the easiest way for your calculator. So I'm going to go ahead and hit 75 second apps degrees, enter, and 40 second app minutes, and hit enter, and you got that. So let's just leave it at 75.667, okay? I like to carry things to 3 or 4 digits, especially when you're working with decimals. So let's leave it at 75.667. And we got to multiply that by what? That's degrees. That's over 1. So we got to multiply that by what? Pi over what? Okay, so I'm going to put brackets around that because we still converting. So y'all do that in your calculator. Now, do I want y'all to write in terms of pi over 1? No. This is a calculator number crunching. This is a word problem. So crunch it out. Multiply the 75.66 times 3.14 over 180 and put a decimal in there. Now, somebody tell me where pi is because I can't see this blue and this green. I see solid. It's under clear. So right there.
Yeah, but you gotta.
It's green alpha. It's alpha. I can't even see it.
It's.
Okay, so I'm going to hit times. Hold on a second. Things I do for y'all. Pi is second, and you said it's right above the caret symbol.
The caret.
Is second. Okay, let me go back. Second. There we go. That's the caret symbol. Okay, enter. Divide by 180. And I get 1.32. So write that out. I'm not going to write it out. So 1 point blah, 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 blah times 9.32. And you should feel good about yourself. 12.31. Now, let me go ahead and warn you. You may be off a little bit. Why? Because pi in the calculator goes to 10 digits. I only went to 3 here. You see what I'm saying? So I may be 100th off. I don't know. We'll see in just a minute. I'll be lenient on this question. Okay? So this would be a question if you put, I'm going to put 12.31. 12.31 what? Well, what is meters, inches? Inches. So it possibly could be 12.30 or 12.32. It could be somewhere in there. So let's see what happens when I punch it in.
I think it wants it to the 10.
What? Well, if it wants it to the 10th, I think we're good. Round to the nearest 10th, so 12.3. And we feel good about ourselves. Now what do we do? This says, in order for the weight to rise 5 inches. So we need, okay, let me say something, one thing. We need to, I need to show you what we just did. This angle turned 75 degrees. Everybody with me? That angle is 75 degrees. So this rope, and I'm going to highlight this rope. This rope right here just traveled how many inches? 12.3 inches. So this right here is 12.3 inches. So you need to realize what you just figured. 12.3 inches. That's what this rope traveled right here. So therefore, if the rope traveled here, how far did the weight travel? 12.3 inches. Okay? You need to realize what you just figured out. If the rope travels 12.3 inches, then the weight traveled 12.3 inches. So in order for the weight to rise 5 inches, what are we going to plug in? 5 right here. What is it, 9.32? I can't see it. 9.32. And what are we trying to find? Theta. So go to it. We're going to take 5 and we're going to divide it by what? 9.32. So somebody take 5 and divide by 9.32, and that's going to equal x, or theta, whatever you want to call it. And what is 9 or 5 divided by 9.32?
Do you want a decimal or fraction?
Just give me the decimal.
How far? 0.534?
5, 3, what?
64,
6, 4?
which I guess you've rounded to 5.
Yeah, give me one more.
8.
8. And that's equal to theta. Okay, now, we've got, this is probably in degrees, and they want radians. That's probably in degrees, so we need to multiply by what? Pi over 180? I don't know if they want it. It says, do not round your final answer. Let's see if they want it in. Help me solve this. They're gonna want it, I believe they want it in radians, but I'm gonna check to make sure.
They want it in degrees and minutes.
Oh, they do?
Yeah.
Yes.
Okay. Get out of that. I trust y'all. I'm just checking on. Sometimes students, they tell me wrong. Okay, I know y'all won't believe that. So yeah, they did. Let's see. They went ahead. Yeah, theta, and they divided by. Yeah, they divided by r, which would be 8.98. They went ahead and multiplied. That's radians. Trying to see what they're doing here. Can't see it because they at one place. Okay, anyway. There. Okay, we multiplied by that. We got the 12 point whatever, and it's determined the rotation. 7 equals 8.98. That's what we did. And they skipped about 3 steps. Okay, so that's good. So I think they gave us 0.53648. Let me see what they do. Okay, so they are doing it. Okay, so multiply it by 180 over pi. Somebody do that for me. I'll do it. Multiply by 180 over pi. So we're going to take 0.53648, 0.53648. Got to turn the damn thing on. Sorry. 0.5. I don't forgot. 53648. And we're going to multiply that by, let's see, it'd be pi over 180 or 180 over pi? 180 over pi, right?
0.536.
I want to make, shoot, 0.546. I might as well just quit.
It's fractions 125 over
648, 648. I'm trying to kill two birds with one stone here. 53648, and we're trying to change it into, so that means we're going to multiply by what? Pi over 180, right? No, 180 over pi, right?
Yeah.
Multiplied by 180 divided by, y'all got a question?
No, sir.
I'm just so anxious to hear y'all talk. I just don't know if it's a question or not. That's why I'm asking. Enter. There you go. Now we got decimal degrees. So what do? We take that and we hit second, half, and go down to degrees, minutes, seconds, and hit enter. And we got 30 degrees, 44 seconds, and 44 minutes, and how many seconds? 17. Now, in the real world, you would put in the theodolite 30 degrees, 44 minutes, and 20 seconds. Because the theodolite doesn't go to a single second. But anyway, 30, 44, 17. So write that down. 30, 44, 17. So we're going to put it, the way of the figure, we already did this, 12. I think it changed it, didn't it? Yeah, it changed it. 5 inches, did we do 5? Okay, there we go. And what did I say? 30 degrees? 44 minutes. It probably wants.
Oh, why did you change the radius?
Okay, the question changed. That's why it's not doing it. So somebody give me the answer to that one. 30 what? Not this one. It was 30, 44 what? 30, 44, 17. That's the answer to this question that Miss Billy sent.
Why did you change it to radius?
It changed when I went to help me solve this. It changed the question. Yeah. So if I go back to her question, if I go back, that's the way it works. If I go back to her question and pull it back up, it'll have the original. There it is. 9.32. It changed it when I went over there. I was just checking to make sure that they were wanting the degree. So, okay, does that help? Hopefully that helps. Nobody's going to say anything. Okay, that's good. Always good to get input from the class. Thank you. Traverse. 9.129. Is this the same one? I guess we're going to do it. I'm not doing 15 of these. But I will do one that's different. So, well, let me see if I can get one with more of a different number. Let's see. Try this one. That's about the same. Try this one. Okay, they're all going to be about the same. So we'll go back to that second one because it was a little bit different. So try this one. I'll let y'all do this one. 9.36 and 74.5 degrees, or 74.50. I'll see if I can blow it up a little bit. But Pendleton won't complain. There you go. Can you see it, Pendleton?
Yes.
half the class says no. I bet half the class that says no, I bet they're sitting on the back row. Hopefully you can see it. Or they're saying no because they hate me, one of the two. That's all right. By the time I get through with this green bottle, I won't care. So hopefully y'all can do this one, and if you can't, you can just mark it down as failure. Failure in life. Failure in classroom, failure in life. That's what I tell my son. Oh, Lord. So the game of the week is going to be what? LSU and Texas, isn't it? And of course, Clemson against Jimbo. Who basically was Florida State. Well, Florida State sucks now, don't they?
Yeah.
They couldn't even beat their opening game. Who'd they play? I think it was like Dorman High School.
What's wrong with Dorman?
Huh?
What's wrong with Dorman?
Dorman is like a little college.
I know, I went there.
That's what I'm saying. I'm saying that the cupcake games that the college games play, their first one is always against a community college or a high school. Georgia played, who did they play? Well, they played Vanderbilt, which they get beat up all the time. And who did, just name somebody. I mean, they play a cupcake game. I think Georgia plays this week. They play their second cupcake game.
Yeah, Auburn plays Tulane.
Yeah, Auburn plays Tulane this week.
Yeah.
Oh gosh, I hope Tulane don't beat Auburn. But that's what I meant. It wasn't it was a compliment to Dorman High School.
I appreciate that.
Usually I say Burns, but you know, I try to spread it out.
Burns suck.
I played Burns one year at West Side when we went to the state. Played Lawrence. That was a hell of a game. And then we had to play Burns, and then we had to play Airport. Why you name a damn high school Airport? I never have understood that.
That's weird.
All right, so let's do this one. S is equal to R theta. So S is equal to 9.36, bracket, and we're going to just put 7450, and multiply by pi over 180. We got to change that, and that should give you the second part will take 6 and will equal 9.36 and multiply that by theta. So that means we're going to divide by 9.36, divide by 9.36, and we're going to multiply that. And always get this is in radians, so that's going to multiply by 180 over pi, I think, yes. 180 over pi, and that should be the answer to B. So let's go back and change that 7450. So take your handy dandy calculator. And if you had a TI 30, it's a whole lot easier with a TI 30. All you got to do is hit the degrees, minutes, seconds button, or you could actually do a hotkey and program the calculator with a hotkey, but I ain't gonna do all that. So y'all can knock yourself out on that one. All right, so I'm gonna move this over. Dang, I shouldn't have wrote on it. There we go. Put it right there. All right, 74. No sneezing in class. Second, degrees, 50. Oh my God, I'm about ready to scream. Well, at least I know. See, Pendleton, I know they hate. They're laughing at me. They like laughing. Okay, so if I fall down and bust my head wide open, are y'all gonna laugh? See, told you. You know those kids the kids that like to see SpongeBob get beat up? That's them. That's the Pendleton campus. When that was Krabby Land. That's when Mr. Krabs opened Krabby Land, and it was about to fall apart. And Krabby the Clown. That was so. I love Krabs. He's funny. Okay, I'll shut up. Second, delete. Second, quit. Thank you. Oh. It's a whole lot aggravating if you ever tried to do a calculator with a mouse.
Yeah,
It's very annoying. Okay, 74, 50. But I suffer for y'all, okay? I do it for y'all. And I'm about ready to scream again. Yeah. Second. Now.
You gotta click the button.
I'm about ready to scream. 50. If I scream, I will probably. I keep hitting second. Okay, somebody tell me what the answer is. 74 point what? 74.833. 833 times parentheses and type in second caret symbol divided by 180, and that should give you your answer of 1.3. Is that what y'all got?
Multiply that right.
Times 9.36. Thank you. Times 9.36. I got 12.2. So 12.2, and we got a good job. We got a star. Now, take 6 over 936, and I'm not going through that. I'm sorry. You can take your calculator and knock yourself out. What do you get? Somebody give me degrees and seconds, and please don't set me up for failure. Please know what you're doing. Huh?
36.
36 degrees?
I think so.
What? 36 degrees?
40.
Yes.
44. And I got to move this back down, thank you. And so there's your two examples of that problem that everybody hates. Okay, so you feel good about yourself on that one now? So we're going to take 29 out. That's going to leave just about, I'll take out about half of it. Let's take that out. Delete. Now 9.130, and I think this is the gears. Yeah. Two gears are adjusted so that the smaller gear is larger. As shown in the figure, if the smaller gear rotates through an angle of 270 degrees, through how many degrees will the larger gear rotate? Okay, so the first thing you got to figure out is what's the distance on this gray gear. going to be 270 times 350, 3.5. But 270 is 3 pi over what? 2. So they give you a little bit of ease by giving you 270 degrees. So I've got to figure the distance traveled by the small gear is equal to 270, which is 3 pi over 2, multiplied by 3.5. So 3 times 35 is 105, isn't it? So that's going to be 10.5 over 2. Somebody check my math. Pi, and 10.5 over 2 is 5.25. 5.25 pi. Somebody check my math and tell me what distance you're going to get. $16 point what?
493.
493 or 49. 16.49 inches. So this gear travels 16.49 inches. So if that one travels 16.49 inches, what does this one travel? 16.49 inches. Now, if both of them travel 16.49 inches, then I can set this one 16.49 inches is equal to 7.3 times what?
8.
And now you can redo what we just did on the previous problem. You know what happens on this problem? People try to start what? Thinking. Distance traveled from the gray to the purple is not the difference. The difference is the torque on the bar behind the gear. That's the difference. Everybody with me? Okay, a lot of people try to start thinking and saying, well, if you take a little gear and turn a big gear, then that's going to be, no, you don't need to think. You're not that high yet. Okay? You need to think about the distance traveled. The distance traveled at 270 degrees on the gray is 16.5 inches. That same distance is going to be relayed to the what? The purple gear. The difference is that the purple gear is a bigger gear, so that torque is going to change. That work is going to change, not the distance traveled. That's what happens on these questions. People try to start, their civil engineering degree in their algebra class. All right, so here we go. Divide by 7.3, and that's going to be 180 over pi multiplied by 16.49 over 7.3. That should equal degrees. Give me degrees in minutes, please. What does it say? Round to the nearest integer. So it may just want a decimal degree. Somebody answered it. They want a decimal degree or what? They don't. They just round to the nearest degree. Somebody give me the nearest degree. What do you get? Please, because I'm not going to type that in with the mouse. I'm sorry.
I got 129.
You got how much?
129.
129. And you feel good about yourself. Now, naturally, the degree on the purple one, will that be greater or less? It should be less, because the the gray one turned 270 degrees. The gray one is not going to turn 270 degrees, and this one turned 300. Think about that. It's not going to happen. It's going to be smaller, okay, the degree, and therefore the torque is going to be different. The axle is going to be turning at a different what? Revolutions per minute. Everybody feel good on that one? Now, the next one is going to be just like it. I want you to do it. So that way you'll have a couple of these in your notebook. So let's make sure the next one is 30. Let's see the next one, next one, next one. Oh yeah, so we'll go, that was yours, Mandy, wasn't it? That was yours. So we'll go with Miss Seabrook. I don't know if it'll be the same or not. Nope. So y'all do this one, and I'll blow it up. Just hold on.
Yeah.
There you go. Is that one big enough?
Yes.
I'm still, somebody up there, no. I can't keep my saying no. But hey,
Yes, what if I give you?
8,000.
it's all right.
Uh-huh.
I'm gonna send my daughter to spy on y'all. I can't ever remember which apartment she's in. You know where Issaquena comes out? It's right there on 93. Is it 93 or 123? Which one is it? 93? I forget. Anyway, that goes to Central. She's the second set of apartments on the right. What's the second set on the right? Can't remember. What?
Is that your teacher?
I don't know. I'm gonna text her and ask her. I always text her during classes just to piss her off. I don't know why she keeps thinking she's gonna graduate. I keep telling her she's not, but she wants to.
Hubert, what do you see on your screen?
What?
What is your screen showing? We're looking at your email, not a problem.
Huh? Did it just happen like that?
It's like it froze.
Did y'all see the last problem?
We did.
Wow. Okay. Let me resend the presentation. Who is that? Is that Oconee?
Oconee, yes, sir.
All right, I'm sending the presentation again. Maybe it'll unstick itself. Tell me if it does something different. I can only see the bottom of y'all's TV screen at Oconee, so what's it doing?
We can see the screen now.
Is it still showing my email?
We can see the problem.
It's the
Okay.
blown up problem.
Okay,
Yeah.
good.
Can you resend it to me as well, Hubert?
I sent it to everybody.
Okay.
It should do it to you also. You might have something blinking that says for accept. I'll do it one more time. Look for something blinking down at the bottom of the screen if you got everything maximized. You might have to minimize your screen and see if it's hiding behind one of your other screens. On page Thursday, I got to pick up my son before DSS does. Yeah, every time I ask her, she says, you don't know where your daughter lives? I said, no, wouldn't be asking if I did. I don't keep up with that stuff. I do good to keep up with my own self. Yep, there it is. You mean you don't know where I live? No. I got 2 mobile homes on the farm she could have lived in. Did she fit? No. Gotta live in Clemson. As soon as she gets out of that, hopefully she'll. I guess people just like to spend money. I don't know. University Village.
I just have the same exact number, so I just plugged mine in.
So Pendleton, where's University Village? Y'all live in University Village?
No.
Yeah, it's over near Blood Bunnies.
Is that where all the meth heads live? That's where my daughter is, with all the meth heads?
Yeah, that and the reserve.
That's probably right. She's probably selling it. So y'all must live, you said the reserve?
Yeah,
Okay, is that
that's right
closer to
beside
Clemson?
each other.
That's closer to Clemson, isn't it?
Well, they're right beside of each other.
Oh, okay. Actually, there used to be a pond back there. I used to do some partying back there. My wife, my ex-wife, lived right across from there. There's a brick house on the hill there. I think it's a real estate agent now. That's where she grew up. There ain't a pond back there, is there? There's a pond back there. They might have covered it up. I don't know. They probably did because drunk asses get drowned, so they probably covered it up. I know some Clemson student go down there and get drunk and drown. But I know Pendleton, y'all don't drink, so that's not direct toward y'all. Okay, so here we go. 300 degrees. What is 300 degrees? What's the pi?
5
5 pi over what?
3.
Multiply that by 3.9 over 1. That goes to 1.3. 1.3, 5 times 13 is 6.5.
Yeah.
Check me on that. That's 6.5 pi. So we're talking about 6 times 3. 6 times 3 is 18, probably 19 something inches. I'm sorry, what?
20.42.
20.42 inches. So if that would move 20.42, then this would move 20.42. And that would be 20.42 is equal to 7.3 times theta divided by 7.3 multiplied by 180 over pi. And somebody tell me how many degrees that comes out to. And I'll go ahead and put 20.42 in here. Oh, okay. How many degrees? 8,541 degrees. I tell you what, somebody's on fire with that 8,000. Woo! That daggum thing is spinning. What does it come out to be?
I think 160.
160, is that what y'all got?
Yes, sir.
And we feel good about ourselves.
How you doing out there? This one? Yeah.
Yeah, that's what she just said, beside the reserve. Okay. So that's that. So now you got 2 of those questions. So now it is 2 of the weights and 2 of the gears. So y'all should feel good about yourself on those. So that'll take care of all the way down to, let's see if this is, that number 30 also. I think that'll take care of all of these. 31. Okay, so let's take these out. And this is probably going to be your area. And we haven't went over that yet. Let's see. Figure shows a bicycle chain, bicycle, how far would the bicycle move? if the pedals are rotated, this is the pedal right here, I'm sorry, here, 180 degrees. So you need to find the distance. And I know it's, what time's class over, just so I remember.
12:30.
5 minutes.
Don't say that. I'm not crazy, okay? See, Pendleton said, who said that? Who said that?
The guy that puts a hat.
Huh?
Said what?
What?
Said what?
Who said it?
I don't know.
Pendleton, who said it? See, Pendleton will say something that gets him out of class. Okay, they laugh at the teacher. They say they get out of class early. Y'all just don't want to be here, do you? Is that what it is? Okay. So anyway, let's take our handy dandy 180 degrees. So no matter where your pedal is, if you want to draw your pedal right here, that's fine. 180 degrees, so that's the distance that they want to find. Now, the distance that you're going to find here is going to be the distance you're going to get here, which means you may get a big degree because that's bigger and it's turning this one. Okay, now it says a figure shows chain drive bicycle, assume the radius of the bicycle wheel is 12.69 inches. Well, that's later. Okay, we got to figure out how much this one moved. Okay, and I don't think I'll be able to get this one in today, but we can go ahead and start on it. So go ahead and figure the distance traveled at 4.591. 4.91. So, and we know this is 180 degrees. So S is equal to 180 degrees times 4.91. And we know that 180 degrees is pi, right? So S is equal to pi times 4.91. And somebody give me that distance. Let's see, what does it say round to? Okay, it does round to the nearest 10. So give me the hundredth.
15.2.
15. I'm sorry. 15.43. Did everybody get that? So this guy turned 15.43 inches. Okay, now remember, there's your bicycle wheel, and there I'm assuming the radius here is 12.6 inches. Okay? So the distance that we traveled here, we got to find what? In order, what matches on this wheel? The distance, I mean the radius don't match, but what does match?
The distance.
Not the distance, but the what? The angle. So you got to find the angle that wheel is turned. The angle that the wheel is turned is the same as the angle that what? The little gear is turned. So we got 3 steps here. 1, find the distance that this thing's turned. Then you can find the what? The angle. So theta, or S, is equal to R theta. And we're trying to find theta. So theta is equal to S divided by R multiplied by 180 over pi. And S is 15.43. And R is 1.76. So that's going to be 180 over pi multiplied by, what I say, 15.343 over 1.76. I need y'all to work that out. And I don't know, I guess just give me a, this is to the whole degree, so just give me a whole degree. I don't know, we may be wrong on this one, but it may be because of rounding, because I don't know how far they want us to go with the degree. I'm just going to assume that this is going to be to the nearest degree. What do you get? I'm sorry, what? I don't think that'd be right, would it? Okay, 502 degrees, is that what y'all got?
Yes.
Yes or no?
Yes.
Okay, so now you've got the degree that I did tell you it'd be more because that would be right. Because if this turns 180 degrees, then it's going to be more. Okay, yeah, shut up, Hubert. Okay, now I've got to put my focus on the wheel because I want to find out how far, if this is 500 and something degrees, then I want to find out how far this travels at 502 degrees. So the distance on my wheel, S on the wheel, is going to equal theta, 502 degrees. Somebody change that to radians. So that'd be 502 degrees multiplied by pi over 180, and then multiply that by, where's the 12.6? And the degrees cancel. Yeah. So I think that's what they're wanting. Assume the radius. How far will the bicycle move? Okay. So the distance that the wheel turns is equal to what? It says round to the nearest tenth. I'm sorry. What? 110.4 inches. Is that what everybody's getting? Now, maybe the only thing I'm worried about is what degree did we get? 502 degrees. Was that an even degree or was there decimals?
There's decimal, but I left the decimal.
Okay. Let's see what we get. And of course, I will be lenient on this question because, like I say, I used 502 degrees because this was to the nearest. There wasn't no seconds or minutes, so that's why I said, shut up, 110.4. And you feel good about yourself. Now, did you keep your 502 in there? Did you keep your decimal in there?
No, I converted it to radians.
Okay, so you just used 502?
Oh, I left the decimal.
You left the decimal. Okay, write that down. She left the decimal at the 502. She left it in the calculator. So you want to leave that 502 decimal in the calculator. What was it, 502 point what?
1402.
Okay, 1402. You want to leave that in the calculator and multiply that, instead of 502, because she got it right, 110.4. Did anybody use 502?
I use 502.
Did it come out with 110.4?
It rounds to 110.
Okay, okay, it's safe. All right, so that's that one. Now I'm glad I showed it to you because now you have it on video for the one person that watches the video, and you've got it in your notebook. So got that, okay? Now let me turn the off.